Hello guys, welcome to my first class of Laplace transform. This Laplace transform is very much useful, especially in engineering course UG and PG. Not only for one field, in all engineering branches, they are very much useful for Laplace transform. We treated Laplace transform as one of the tools to solve the given differential equation, or we have to say that is just you have to treat it as a tool to take a decision for the given problem. No, this is actually Laplace transform is a very vast, it's a very much useful, not only Laplace transform, inverse Laplace transform also. This beauty of Laplace transform is, now we have to convert one type of function to another type of function. Usually the time domain function they convert into frequency domain function. Let us come to that part later. Now the question is arise, even the engineering students or degree students or maybe medical, whatever may be, they are going to study for Laplace transform. What's the use to study for Laplace transform? What are the applications having the Laplace transform? Now Laplace transform having so many applications. Here I have quoted some few things. One of the application is the control engineering, they using Laplace transform to take a decision. Communication also they going to use Laplace transform. Signal analysis and designing, there also they using Laplace transform. System analysis, there also they using Laplace transform. Solving general linear differential equation, there also they using Laplace transform. Not only this, in the computer science field, they're going to use cryptography, they passing a message from one end to another end. They are going to use one of the method is nothing but Laplace transform. Means encryption and description, they are going to use the one of the mathematical mode is nothing but Laplace transform. Not only they are using in engineering level, they are going to use in business also, in means finance. No, they are going to take, they are going to collect whatever the demand and price. Based on that, they formulate the differential equation. They are solving a differential equation by using Laplace transform. Therefore, not only they are using engineering, they are using in the business field also, and chemical engineering, physics, chemistry, everywhere, because whenever having a differential equation, we are going to solve by using Laplace, because Laplace transform is solved very easily compared to direct method. Direct method means ordinary differential equation. There we want to find out complementary function and also have to find out particular integral. Instead of that, we are applying Laplace transform. We get very quickly without finding the complementary function and particular integral. And the one drawback for Laplace transform, we can't find out general solution for differential equation. Only I have to find out particular solution of the given differential equation. Means whenever the differential equation having a boundary values, there is possible I go for Laplace transform. Whenever they are not mentioned boundary condition, you can't go for Laplace. Means Laplace is a fail to solve the differential equation. But usually in the core subject, in all application oriented problem, definitely once you form a differential equation, then definitely have a boundary conditions. Therefore, if you want to open any research paper, including chemistry, physics, finance, or any mechanical engineering, chemical engineering, whatever may be, in all the field, whenever we get a differential equation with boundary condition, they are going to solve by using Laplace. Why? Because Laplace is a very simple, easiest mode to solve with respect to the boundary condition. I told just now what's a drawback, what's the advantage. Now because of that, we are studying Laplace transform. Basically, Laplace transform is not come directly. We are defining a Laplace transform based on one of the transform is called integral transform. Integral transform start with the first letter is I. Therefore, integral transform of the function f of x is nothing but integration of x1 to x2 k of sx into f of x dx. This is nothing but the formula dx. This is nothing but formula for integral transform for the function f of x, where k of s of x is nothing but kernel of the transform. This kernel may be a function, is a exponential function, logarithmic function, trigonometric function, what about the complex function also. Once you give different function, we get the corresponding different transform. Now totally kernel is nothing but is a function of both s and x, where s is a parameter of the transform. Instead of this, in some standard for textbook, they are going to consider alpha also. Some of the textbook they consider as omega also. All must be, this is nothing but parameter of the transform. Once you give a different function, that gives us different transform. Based on the transform, we are going to change the limit. Sometimes we are going to take 0 to infinity. Sometimes we are consider minus infinity to infinity. Solve. For example, the kernel, say s of x, must be equal to e power. I am going to consider it whatever exponential function that implies 0 to infinity e power minus sx into f of x dx. With respect to x is nothing but Laplace transform for the function of x, where s is a parameter. Once you evaluate this function integral, apply the upper and lower limit, finally we get in terms of parameter or maybe a constant, that is denoted by capital F of s. Suppose the kernel is equal to trigonometric function that gives rise cosine transform, sine function that gives rise sine transform, suppose equal to complex function that gives rise complex Fourier transform. Therefore, this Laplace transform we can't define directly. This is one of the particular case of integral transform. I think everyone is clear how to define Laplace transform for the function. It's a particular case of which one? Integral transform. Now, once again I am going to write what's the formula for Fourier, whatever the Laplace transform for the function f of x. Laplace start from here, therefore I am going to write L of f of x must be equal to 0 to infinity. Kernel is nothing but my e power of minus st. We are changing t because I tell you later why f of t dt. Once you evaluate this, we get a value in terms of parameters, say yes or maybe a constant. Just 2 minutes back I told, once you apply Laplace transform, is convert one type of function into another type of function. Now you see, observe this is nothing but pictorial representation of Laplace transform. Now time domain. Usually we are talking about, I told this is useful way in signal analysis and design. They are having a signals we are considered based on the time domain. Now once you apply the time domain for Laplace transform, the mode is nothing but I am using a tool is nothing but Laplace transform. You convert into which domain? The convert in terms of f of s. F of s is nothing but our frequency domain. In mathematics we are taking s, but there in our optional book they are going to consider omega. That is nothing but frequency domain. Once you apply the Laplace, time domain is converted into what? Frequency domain. Once you apply the inverse Laplace transform based on the frequency domain, that gives us time domain. This is nothing but pictorial representation of Laplace transform. Therefore, L inverse of f of s give rise our whatever time domain function is a f of t. That's why we have considered t in the mathematics also. But keep in mind in your optional subject in signal system, and then signal system that comes in where actually electrical engineer, electronics engineer, telecommunication and EIE students. The same thing they are going to consider where actually mechanical students they are going to learn for mechanical vibration. Like that, civil engineering students they are going to learn for Laplace, Fourier series, Fourier transform, and to analysis what's the life of this bridge, what's the life of this building. In such cases, they are going to use Laplace. Why? Because now I told signal and system, they are going to convert, they are going to record time. Time may be having maybe a negative or positive like that signals. Based on the time we are going to connect the signal. The signal become a what? Waves. While come to the mechanical vibration, they convert into waves. In these two ways, in the same form, you are using one of the mode is nothing but Laplace transform. They start from different mode, finally they reach one mode, they want to solve that wave I have to solve by using Laplace transform. Like that, civil engineering students, they want to give what's the life of this bridge, they are going to put one mission in the what about near to the bridge, they are going to collect the vibration of the whatever two-wheelers and four-wheelers vibration. They convert into form of vibration in the form of waves. They want to take a decision. They are going to use Laplace, Fourier series and Fourier transform. Therefore, then I told computer science students, they want to pass the secret message from one end to another end. They are going to use, it means cryptography. They are going to use Laplace transform. Now, therefore, even though any field, chemical or mechanical, whatever may be, this Laplace transform is one of the important tool to take a decision for the thing. I am going to discuss in further classes in depth of Laplace transform. Thank you very much for listening my talk.